This is the example video for the lesson on graphing and solving quadratic inequalities. For number one, we have to graph y is less than a quadratic. So here I'll just go ahead and start by putting down my axes. And now let's maybe try simplifying this because I can't just look at this quadratic and know what it looks like. So this is really the same thing as x squared minus 2x. Well, let's think about completing the square again. I could say plus 1 plus 2. And all of this stuff can be expressed as x minus 1 squared plus 2. So there I go. I've simplified y is less than that now. This is just my regular old x squared graph, shifted 1 to the right and up 2. So normally I'd start here and I'd open up, but I'm going to go 1 to the right and up 2. And it opens up the same way that a normal x squared looks like. So that was my graph. That's what the graph of the function looks like, but I'm trying to find y is less than that function. So actually what I'm going to do is put dashes in where the function is, because I don't quite reach that function exactly. And I'm going to shade everything below the function. And that's the graph. For number 2, I'm given this quadratic is less than or equal to 0. Let's start by solving the quadratic equality, the equation where it's equal to 0. Well, r would equal negative b, in this case that's negative and negative 3, so 3 plus or minus the square root of b squared, that's 9, minus 4ac, all that over 2a. Well, that is just 3 plus or minus the square root of 9 plus 16 all over 4, or 3 plus or minus 5 over 4. This can be simplified two ways. 3 minus 5 is negative 2, and negative 2/4 is negative 1/2. And the other alternative is 3 plus 5, which is 8. 8 over 4 is 2. So this means I can rewrite the original equation as r minus negative 1/2, r minus 2 is less than or equal to 0. To solve this now, I'll say that this has to be a positive number and this has to be a negative number. And keep in mind, r minus a negative 1/2 is just r plus a positive 1/2. So on the left I have r plus 1/2 is a positive number, and it could be equal. On the right I have that r minus 2 is a negative number, and it could be equal. So on the right, this is r is greater than or equal to negative 1/2, or on the left, and on the right we have r is less than or equal to 2. So greater than a negative number, less than a positive number. And note that both of these things have to be true. If one of them is wrong, then I don't have a positive times a negative. I could have a negative times a negative, or a positive times a positive, which is not what I want. So both of them are true. And in fact, you can rewrite them so we know r is less than or equal to 2. But r is also greater than or equal to negative 1/2. So that is the solution. For number 3, we have to solve another quadratic is less than or equal to 0. There are a couple ways to start this off. What I'm going to do first, though, is I'm going to get rid of that negative in front of t squared. I'll explain why afterwards. So here, if I multiply everything by negative 1, I get t squared minus 4t plus 4, and I have to switch this sign now, so it's greater than or equal to 0. You may recognize this for being a perfect square. This is actually t minus 2 squared. is greater than or equal to 0? Well, any number squared is greater than or equal to 0. We know that for a fact. You can't square something and get a negative unless it's I or something strange like that. So the solution here, all real numbers. T can be anything that's a real number, and this works out. Now let me explain briefly why I decided to multiply by that negative. In the lesson video, we said that if we had x minus some number and x minus another number was less than 0, the solution would be that x is between one number and the other number. If it were less than or equal to, I could actually just put these equal to signs, and that's correct. What's neat is that this is always true. If I have this less than here, then I could always know that it's going to look like this. It's not going to be something or something else. It's always going to look like that as long as a is a positive number. As long as that coefficient of your squared term is positive, you can do this. If it wasn't, you might have to do a little more work, but you would find that it's the same thing. You'll get this answer. We also said that, similarly, if we had x minus a number and x minus another number is greater than or equal to 0, the solution was with an or. X could be greater than or equal to the big one, and x less than or equal to the small one. This is also always true, that this will give you the or, as long as you keep your a positive. If you don't keep that a positive, then you're going to have to do a little more work to get the same answer. But the best way is to just keep that a positive, and to just remember, less than gives you an and statement. Greater gives you an or statement.